we know that one of the purposes of our vehicles is to take flywheel horsepower and convert it into motive power, right? Motive power means we can push or pull on something. And for a tracked vehicle, we would take the weight or the dead load multiplied by the coefficient of traction is our available pull. And then we would look up, and as we had our gears, this would be our speed, and this would be our drawbar. And so we would take our vehicle production, how much work we're doing, what our load is, and we come over to this gear and see how much drawbar pull we had and at what speed. And that's how we did dozers, and that's how you do all tracked vehicles. But rubber tires are more complicated. Oh, I've forgotten how much fun this is. A rubber tire does several things. And we're going to look at this rubber tire in plan and in section. So this is our tire in elevation. This is our tire in section. We have a load from the vehicle that is pushing down on the axle, and we are going to rotate the tire in this direction to go forward. Our tires are generally pneumatic. Does anyone remember what pneumatic means? Anyone? No one wishes to volunteer? Are you sure? So pneumatic means the tires are under pressure. And this tire is exerting this pressure in all directions. And so it inserts this pressure in all directions, including to the side and down. And we have a concept that we call rim pull. And rim pull is the force available at the tire perimeter. So that force available at the tire perimeter is what we can use to do work. And so if we think about it, what this means is that we have a force here at the tire perimeter. This is the radius of the tire. This is our rim pull value. And this is why you frequently see very large tires on vehicles, because this rim pull is a torque or a moment, right? It's a force plus a lever. And the ability of the vehicle to push against the soil is its rim pull, and of course its rim pull has to be multiplied by the coefficient of traction to get the effective force. This is our available force. But because of the nature of rubber tires and their pneumatic condition, and therefore an exposure to pressure in all directions, if you look at a tire operating on a soft surface, you'll see that it's doing this. That there is some soil that sits at some angle, don't know what it is, as the vehicle is typically pushing into the soil. And this has the effect of the vehicle always going uphill. Because it's climbing out of a hole that it's creating itself. And so we have what is referred to as the rolling resistance. You've all experienced it in the past. If you park a vehicle and it is in neutral, but the wheels are free to turn, it has to get up to a certain slope before it will fall or slide along that, or rather roll along that subgrade. And so this rolling resistance is an angle that is related to the vehicle perpetually crawling itself out of the hole that it's creating by its load plus the tire pressure. So we talk about contact pressure giving us a contact area of the tire. The concept is important because we can increase or decrease that contact pressure and therefore increase our tractive power by inflating or deflating the tires. Does anybody have a truck that you can control the air pressure in the tires from the cab? There are people that do, and in fact, most of the ready-mix trucks that our friends operate in the world took this traction from the military. So if we have a high pressure tire, we have a low contact area. If we have a lower pressure tire, then we have a higher contact area and we get more traction. Low pressure tire, high pressure tire. And so the ability to determine how the vehicle is going to perform is a function of changing its rolling resistance and the tire pressure. And most of the vehicles that we would think about that are operating on construction sites, operating on unmetalled or unpaved roadways, are going to interact a great deal with the interact a great deal with the soil. And so this rolling resistance can be translated into an equivalent grade resistance. And we'll talk about how to do that the next time we're together. So what it means is that if I'm going up a hill at a 10 degree slope, if my rolling resistance is determined to be an equivalent of a 4 degree or 4% slope, whichever one it is, let's stay with 4 degrees. Then going uphill, I have an opposing slope. (10°). And then I have a rolling resistance that's equal to 4 degrees. So my total opposing is 14 degrees. And so it's the equivalent, even though the grade is only 10 degrees, of trying to climb a 14-degree opposing slope because we have our rolling resistance. And rolling resistance is always resistance in that same grade area. If we go down the hill, then we have an assisting slope, right? Easier to roll downhill than it is uphill. And that slope is equal to minus 10 degrees. Our rolling resistance is still 4 degrees. And so our net slope or net resistance is 7 degrees assisting. So even though we're going downhill in one case and uphill in the other, the rolling resistance remains about the same. So the rolling resistance makes climbing hills harder, and it makes going downhill worse. So in these particular cases, we have to take this into account. And the way that we do it is we will convert our vehicle loads into a rolling resistance. So rolling resistance, a very important concept that only exists in wheeled vehicles because of their relatively small contact area. So what I'm going to do, because this isn't the clearest writing I've ever done, I'm going to get this writing cleaned up. And when I have this writing cleaned up, then I'm going to get this posted with some additional information. But basically, rolling resistance is a concept that we use to describe the fact that the truck is perpetually, or the wheel is perpetually attempting to climb out of a hole. And what we're going to find is that depending on our soil type and our degree of compaction and our degree of rutting, we have a different rolling resistance. So we need to control rolling resistance, and we do that using that motor grader that we saw before. So that's where I'm going to end it off today, only because I don't have, in my scramble yesterday, having resources taken away caused me no end of difficulty. I'm going to download this. Did anyone look on Canvas for the recorded presentation from last time? So if you do, there is one there. We're going to close things off right now. We'll be back at it at 8:30 on Monday morning. We're going to look at a set of problems that and some data and how to read charts that are found in that will be found very shortly on Canvas. Does anyone have any questions before we close?